Imagine falling into darkness where even light cannot escape alive. A black hole begins, where gravity becomes stronger than anything imaginable. Not even photons, the fastest travelers, can break free from it. The boundary is called the event horizon, a point of no return. Crossing it means the universe outside will never see you again. From afar, you appear frozen, slowly fading at the horizon's edge. But from your perspective, everything continues in a terrifying normal flow. Time behaves strangely, stretching and slowing under immense gravitational pressure. Every second near a black hole equals years far away. Your body starts feeling unequal forces pulling different parts apart. This effect is known as spaghettification, stretching you like thin strands. Your feet feel stronger gravity than your head simultaneously. The difference grows rapidly as you fall deeper inside. Bones, muscles, and atoms struggle against overwhelming tidal forces. Eventually, structure fails, and everything stretches beyond recognition completely. Yet, strangely, you might not feel anything at first. In supermassive black holes, the transition can seem almost smooth initially. The real chaos begins deeper within the mysterious interior. Space and time start switching roles in unimaginable ways. Moving forward in time becomes impossible to avoid completely. You are forced toward the center, no matter what you do. This center is called the singularity, where physics breaks down entirely. Density becomes infinite, and known laws collapse into uncertainty. Scientists still debate what truly exists at this core. Some theories suggest matter compresses into infinitely small points. Others imagine exotic states beyond human understanding and current physics. Inside, distances lose meaning as space-time curves infinitely inward. Directions become meaningless as all paths lead to the singularity. Light itself bends inward, unable to escape or turn around. Communication with the outside universe becomes forever impossible now. Signals you send never cross back beyond the event horizon. To outsiders, your final moments appear slowed and dimmed forever. They never see you actually cross into the black hole. Instead, you seem to freeze just before disappearing completely. Meanwhile, you experience a continuous fall deeper inside the void. Time outside races ahead while your journey feels strangely normal. The universe ages rapidly while you approach the unknown center. Stars evolve, galaxies shift, and civilizations rise without you noticing. Inside, reality becomes more distorted than any human imagination. Gravity shapes everything, controlling motion, time, and even existence itself. Some theories suggest black holes could connect to other universes. These hypothetical passages are often called wormholes by physicists. However, no evidence confirms safe travel through such mysterious tunnels. Most likely, anything entering is destroyed long before reaching anything else. Quantum effects may also play strange roles near the core. Particles could behave unpredictably under extreme density and curvature conditions. Hawking radiation slowly causes black holes to lose mass over time. But this process takes longer than the current age of universe. For stellar black holes, evaporation happens incredibly slowly beyond imagination. So once inside, escape remains impossible for any known process. Information paradoxes raise deep questions about what truly happens to matter. Does information vanish, or is it somehow preserved secretly forever? Physicists continue debating this unresolved mystery intensely, even today. Black holes challenge everything we know about reality and existence. They force us to rethink time, space, and fundamental physical laws. Entering one means confronting the ultimate limits of understanding. No human has ever experienced this journey directly, thankfully. Yet simulations and equations give us glimpses into the unknown. Each discovery reveals more questions than clear, definitive answers. The deeper we study, the stranger the universe appears. Black holes remain both terrifying and fascinating cosmic mysteries. They hide secrets that could reshape physics forever someday. Inside them, reality itself bends beyond recognition and comprehension. And still, we continue exploring these dark giants relentlessly, because understanding them means understanding the universe at its deepest level. Now imagine crossing the event horizon, where return becomes forever impossible. There is no visible line, just a silent transition into darkness. Everything feels normal at first, which makes the danger even greater. But outside, time begins racing forward at unimaginable speeds. Light from distant stars appears brighter and more energetic suddenly. The sky compresses into a glowing ring surrounding deep darkness. This happens because gravity bends space-time around your entire view. You begin seeing distorted images of the universe all at once. Light paths curve, showing scenes from multiple directions simultaneously. It feels like reality folding inward into a single strange moment. Meanwhile, gravity grows stronger as you fall deeper inside. The pull becomes unstoppable, guiding you toward the unknown center. You cannot slow down, stop, or change your direction anymore. Every possible path leads inward with no escape available. Even turning around still moves you closer to the center. Space itself is carrying you forward like a powerful current. This is not falling through space, but space moving itself. The idea of standing still loses meaning in this environment. Every direction becomes the same, leading toward the center point. As you descend, tidal forces slowly begin increasing around you. Your body stretches gently at first, then more noticeably over time. Different parts experience slightly different gravitational strengths simultaneously. This difference increases steadily as you move deeper inside. Over time, the stretching effect becomes impossible to ignore. Eventually, matter begins losing its original structure under pressure, but before that, something even more unusual might occur. Your sense of time may begin changing in unexpected ways. Moments might feel longer or shorter than normal experiences. You could see distant cosmic events happening faster than usual. It may feel like watching time speed up outside. These effects depend on extreme gravitational conditions around you. Scientists continue studying these behaviors through theories and simulations. Many details about this process are still not fully understood. As you go deeper, space-time curvature becomes more intense. Geometry begins behaving differently from anything experienced before. Straight paths curve, and distances lose their usual meaning. The idea of position becomes harder to define clearly. Movement feels less intuitive and more difficult to understand. Energy levels around you continue increasing steadily and safely described. Radiation may become stronger depending on the black hole environment. Smaller black holes create stronger effects over shorter distances. Larger ones allow a longer, smoother journey inward initially. Supermassive black holes stretch the experience over more time. However, the final outcome remains the same in all cases. No known force can fully resist the inward gravitational pull. Even light cannot escape once inside this region. Information carried by matter becomes trapped within the black hole. This raises important questions about how information behaves. Some theories suggest information stays encoded at the boundary. This connects to ideas like the holographic principle in physics. It suggests reality might store information on lower dimensional surfaces. If true, nothing is truly lost, only transformed differently. However, this concept is still under scientific investigation. Inside, your journey continues steadily toward the central region. The singularity lies ahead as the final destination. Forces continue increasing as you move closer toward it. Known physics models become less reliable in extreme conditions. Gravity and quantum effects become harder to describe together. Scientists are working toward a unified theory to explain this. Until then, black holes remain deeply mysterious objects. They challenge our understanding of space, time, and reality. Each discovery reveals new layers of complexity and curiosity, yet the true nature of their interiors remains unknown. And the deeper you go, the stranger everything becomes. Because inside a black hole, familiar rules no longer fully apply. As you fall deeper, reality begins shifting beyond anything familiar. Space and time stop behaving like separate dimensions entirely. They merge into one flowing path that always leads inward. Every moment pushes you closer to the mysterious center ahead. There is no way to pause or escape this motion anymore. The future becomes a fixed path you cannot change. Unlike normal life, choices no longer affect your final outcome. All possible directions now point toward a single destination. This creates a feeling that is both calm and unsettling. Meanwhile, the universe outside continues changing at extreme speeds. Long periods pass outside while your experience feels much shorter. Stars evolve, and galaxies shift far beyond your awareness. Light from distant events reaches you in unusual, distorted ways. The sky appears filled with stretched and curved glowing patterns. Light bends around you, changing how everything looks. You may see multiple versions of the same object at once. This happens because light travels along curved paths nearby. Your vision becomes complex and difficult to fully understand. Direction loses meaning as everything points toward the center. Orientation becomes impossible to define clearly in this environment. Gravity now controls every part of your experience completely. It shapes motion, perception, and even how time feels. As tidal forces grow, your form continues stretching gradually. The difference in gravity across your body keeps increasing. Over time, this stretching becomes stronger and harder to resist. At deeper levels, even small structures begin separating slowly. Matter starts losing its usual form under intense conditions. Eventually, structure cannot remain stable in such an environment. This leads to questions about what happens to information. Physics suggests information should never completely disappear, yet black holes seem to hide or transform it somehow. This creates one of science's biggest unsolved problems. Some ideas suggest information escapes very slowly over time. This is connected to a process known as Hawking radiation. It allows black holes to release tiny amounts of energy. Over extremely long periods, this can reduce their size. Another idea suggests information stays at the boundary surface. It may be stored in ways we do not fully understand. This connects to the concept of holographic descriptions of reality. It suggests deep links between dimensions and stored information. Black holes provide clues supporting these advanced scientific ideas. As you move inward, space-time curvature becomes extremely strong. Distances behave differently, stretching and shrinking unpredictably. Paths no longer follow simple or straight directions anymore. The laws of physics begin reaching their known limits. Gravity grows stronger as you approach the central region. Density increases beyond what current models can describe clearly. At this stage, equations fail to explain what happens next. Scientists need better theories to understand these extreme conditions. A unified theory could explain both gravity and quantum effects. Until then, the center remains a scientific mystery. Some ideas suggest connections to other regions of space. Others describe it as the end point of all known paths. There are also theories involving transformation rather than destruction. However, none of these ideas are fully confirmed yet. Your journey continues steadily toward this unknown region. Each moment brings you closer to the central point. There is no way to turn back or slow down. The outside universe becomes less relevant as you continue inward. Everything now focuses on the path ahead of you. Reality narrows toward a single, unavoidable conclusion. What lies ahead remains hidden from complete understanding. Science continues searching for answers to these deep questions, because beyond this point, knowledge reaches its limits, and the true nature of reality may finally become clear. Now you are incredibly close to the most mysterious point inside. The singularity lies ahead, hidden beyond the limits of understanding. Every moment pulls you closer without any possibility of stopping. Gravity here becomes stronger than anything ever experienced before. Space-time curves so deeply that normal physics cannot explain it. Distance and direction lose their meaning completely at this stage. The concept of location itself becomes unclear and unstable. Everything collapses toward a single point of extreme density. This point is where current scientific models completely break down. Known equations cannot describe what truly happens here anymore. Gravity appears to become infinitely strong at the center. Density rises beyond anything measurable or clearly definable. Space shrinks, while time behaves in ways we cannot fully predict. The laws of physics stop giving reliable answers in this region. Scientists believe a deeper theory is needed to explain everything. This theory would unite gravity with quantum physics completely. Until then, the singularity remains one of science's biggest mysteries. Some ideas suggest matter compresses into an extremely tiny state. Others suggest new forms of matter may exist under these conditions. There are also theories involving transitions into different regions. However, no direct evidence confirms any of these possibilities. As you approach, tidal forces reach their strongest levels. Any remaining structure continues stretching beyond recognition completely. At this point, matter behaves very differently from normal conditions. Particles may lose their usual relationships and interactions. Energy and matter become difficult to distinguish clearly. Everything is dominated by extreme gravitational influence. Your journey becomes less about movement and more about transformation. The closer you get, the less familiar reality becomes. Concepts like shape, size, and time lose their usual meaning. Physics enters a zone where predictions become highly uncertain. Even advanced theories struggle to describe this environment accurately. Some scientists explore the idea of quantum gravity effects here. These effects may prevent true infinite density from forming. Instead, they might create a very dense but finite structure. This could change how singularities are understood completely. Other ideas suggest space-time could bounce under extreme pressure. This bounce might lead to expansion into a different region. Such concepts remain theoretical and not yet proven. Black holes continue challenging everything we know about reality. They force scientists to question the nature of existence itself. Each study reveals new possibilities and deeper questions. The closer we look, the more complex things appear. Inside, everything is governed by forces beyond everyday experience. The singularity represents the ultimate limit of current knowledge. Beyond it, our understanding simply does not reach. Yet this mystery continues inspiring scientific exploration worldwide. Researchers develop new models to better explain these conditions. Advanced simulations help visualize what cannot be directly observed. Still, many answers remain hidden within these cosmic objects. Black holes act like natural laboratories for extreme physics. They reveal how the universe behaves under maximum limits. Understanding them could unlock deeper truths about existence. As you reach this final region, everything becomes uncertain. The path ends where knowledge itself cannot continue. What happens next remains one of the greatest unknowns. Science has theories, but no complete answers yet. This makes black holes both fascinating and deeply mysterious. They represent the edge of what humans can currently understand, and possibly the beginning of entirely new discoveries. The journey inside leads to the ultimate scientific question. What truly happens at the very center of everything? The answer may change how we see the universe forever. Until then, the mystery continues drawing curiosity and research, and the story of black holes remains far from complete. Now we reach the final question. What truly happens at the end? Inside a black hole, the answer remains one of science's greatest mysteries. The singularity marks a point where understanding completely fades away. Everything we know about physics stops working beyond this boundary. Yet scientists continue searching for answers to this deep question. One possibility suggests information is never truly lost forever. Instead, it may be preserved in ways we cannot easily detect. This idea connects to the laws of quantum mechanics. It suggests the universe always keeps track of information somehow. Black holes challenge this idea in very surprising ways. They appear to trap information with no clear path outward. This creates a conflict between major areas of physics. Solving this conflict could change science completely. One theory suggests information slowly escapes over long periods. This happens through a process known as Hawking radiation. It allows black holes to release tiny amounts of energy. Over vast time, this can reduce their overall mass. Eventually, a black hole could completely disappear, but what happens to the information it contained remains unclear. Another theory suggests information stays stored at the surface. This surface is known as the event horizon boundary. It may act like a recording layer for everything falling inside. This idea is linked to the holographic principle. It suggests reality may be described in fewer dimensions. If true, our universe could be more complex than it appears. Black holes provide important clues supporting these possibilities. Some scientists also explore connections to parallel regions of space. These ideas involve tunnels or bridges between distant points. However, such concepts remain theoretical and not confirmed. Most evidence suggests anything entering cannot return safely. The extreme conditions make survival impossible in all known scenarios. Even basic structures cannot remain stable inside for long. Matter transforms under intense gravitational pressure continuously. Energy and particles behave in unfamiliar and complex ways. The deeper you go, the less predictable everything becomes. This makes black holes powerful tools for studying extreme physics. They reveal how nature behaves at its absolute limits. Understanding them could unlock new scientific breakthroughs. It may even help explain how the universe began. Some theories link black holes to the origin of new universes. These ideas suggest each singularity could start a new expansion. While fascinating, these ideas remain unproven for now. Still, they inspire scientists to keep exploring deeper questions. Black holes remind us how much we still do not know. They challenge our assumptions about space, time, and reality. Each discovery opens the door to even bigger mysteries. The journey inside a black hole is beyond human experience, yet, through science, we can imagine and study it safely. Equations, simulations, and observations guide our understanding forward. Step by step, we move closer to uncovering hidden truths, but the final answer still remains just out of reach. This is what makes black holes so fascinating to explore. They sit at the boundary between knowledge and the unknown, and they continue pulling curiosity just like their gravity. One day, we may finally understand their true nature. Until then, they remain one of the universe's deepest mysteries, a place where reality bends and knowledge reaches its limit, a place where questions matter more than answers, and where science continues its endless search for truth, because understanding black holes means understanding the universe itself, and perhaps even understanding our own place within it. The mystery continues, inviting us to keep exploring further. The story is not over, it is just beginning, and the universe still holds many secrets waiting to be discovered, including what truly happens inside a black hole.